These are the class notes on electromagnetic waves or electromagnetic spectrum. And the essential question, how do electromagnetic waves transfer energy through matter or space? So we have some vocabulary, and we've been doing this. This should be a no-brainer. A wave, any disturbance that transmits energy through matter or empty space. And wavelength, the distance from one crest of a wave to the next, or trough to trough, or we just did one in some other notes where it started kind of here at the resting position and it went down and in to the next resting position. So remember, there's a few different ways, but this one's saying crest to crest. Topic question 1. What is an electromagnetic wave? Electromagnetic waves transmit energy through matter or empty space. An electromagnetic wave begins when a charged particle vibrates, causing the electric field around it to vibrate as well. And continuing on, the two types of vibrating fields combine to create an electromagnetic wave. So you've got the electric field, and the vibrating electric field creates a vibrating magnetic field, and then you've got the wave direction. So here's the picture. How does an electromagnetic wave travel? An electromagnetic wave is a transverse wave because the electric and the magnetic fields that make up the wave are perpendicular to each other. And we talked about that a little bit yesterday in the notes we did in class, where if the wave, when you have a transverse wave, is traveling in this one direction, and then here's the wave going like this, but the particles, it could be, the wave is traveling in this direction, but the particles are kind of moving in a different direction, the opposite, or kind of perpendicular. And the transfer of energy by electromagnetic waves is called electromagnetic radiation. And all types of electromagnetic radiation travel at the same speed through space, the speed of light from the sun to the earth. Question 3, what are the types of electromagnetic radiation? The light that our eyes can see is just a sliver of the total amount of light that surrounds us. Night vision goggles help us to see wavelengths of light that are not normally accessible to our eyes. And we just talked about that last video. When we looked at the whole spectrum, we can only see somewhere about in the middle, which is visible light. And here's what the waves look like in electromagnetic spectrum. The electromagnetic spectrum describes the entire range of light that exists. And we could probably see about right here. So you've got radio waves way down here at this end, emitted at radio and TV stations. Radio and TV convert these waves into sound and picture, and they're like the largest wavelength. And then next, you have microwaves emitted by a power source in a microwave oven. Water molecules absorb microwaves and increase the temperature of food. Infrared radiation. We sense this radiation as heat because it causes molecules to vibrate, used in heat lamps for reptiles. Visible light. The only light that our eyes can see, and our eyes detect this light as colors. In a rainbow, the shortest wavelength of color, violet, is closest to Earth, and the longest wavelength, red, is at the top of the arch. Ultraviolet radiation. We need to wear sunscreen to protect our skin from this type of radiation. Bees can see UV light, and so many flowers have UV patterns on their petals to attract bees. X-rays. Bones and teeth block X-rays, making it possible to take pictures of them. And gamma rays. Extremely high frequency waves that are emitted during a nuclear explosion and by radioactive materials. In topic 4, how do wavelength and frequency differ between the different types of electromagnetic radiation? Since we can't see almost all of the types of electromagnetic radiation, we can use examples to help us visualize the size of each wave as a diagram, from the longest to the shortest. And I like this, it really does help give you a visual how big these waves really are. So radio waves, so imagine that are like the size of a building, which is gigantic if you think about that. Microwaves are like the size of a fly. So can you imagine going from this to this size? Infrared is the size of a needle point. Invisible light is the size of a microorganism. And ultraviolet, the size of a molecule, so we wouldn't even be able to see that. X-rays are the size of an atom, and gamma rays are the size of the nucleus of an atom, like down here. So frequency, study the diagram and imagine the wave's motion. What is meant by a wave's frequency? And we've been talking about this a lot, and you've got low frequency here, right, and high frequency here. And frequency has to do with what? How many waves can pass through a point in a second. So if you had this size, not very many are going to pass through the point in a second. And if you had something like gamma, a whole bunch are going to pass through in a second. Topic 5. How does light break into the visible light spectrum? Oops, go back one. A prism breaks white visible light into the colors of the rainbow, Roy G. Biv, which each have a different wavelength. Red has the longest and violet has the shortest. Color each section of the rainbow coming out of the prism. Red should be at the top up here. And there is a great video, and they're asking you to watch this video. I put that TED Ed video in, and then I also, like I said in the last video, put another video that kind of shows you light going through a prism and what happens there. So make sure you do that, and then please write a $2 summary of the video. Each word costs 10 cents, so make sure that's how much again? About 20 words.